In this video, we're going to talk about our first non-carbon functional group, which is a little bit of a misnomer because they are treated like subgroups. So halides are fluorine, chlorine, bromine, and iodine. It is possible to make carbon to halide bonds. And so you can have things like CH3F. You can have trifluorochlorocarbons. Hey, fluorochlorocarbons, CFCs. These are a major problem with ozone degradation. So CFCs are what was breaking down the ozone layer. They used to be used as refrigerants, and so we kind of banned their use. They're still showing up in some places, but they allowed us to actually start to save the ozone layer. So while the modern world occasionally debates whether human activity can affect the atmosphere, we already know that yes, it can. We saw it before. We had international treaties made, and we've managed to repair it mostly. So while we head into global warming, and groups try to pretend that it's not possible for humans to affect the atmosphere, we already know it can. We've done it before. We made huge holes in the ozone layer around the Arctic and Antarctic. But it comes from these halides. Normally what will happen is you'll just have a molecule, and then there'll be some fluorines taking the place of hydrogens. Because halides tend to make one bond, they just replace a hydrogen and take a spot. And so how do you go about naming them, though? Well, as we learn future functional groups, they all have suffixes. So ane, ene, ein are what we've learned so far, and we'll learn many more endings to names. Halides are the only functional group that is a prefix. And so how they get written, your fluorine becomes a fluoro. Your chlorine becomes a chloro. And then bromine is a bromo. And iodine is iodo. And so they're just prefixes at the front of the name. So how would we name this example molecule over here? Well, it's got 1, 2, 3, 4 carbons. So it's going to be a bute. And the carbon-carbon bonds are all single bonded, so it is a butane. But it does have, well, we want our groups to be as small as possible. So we number that 1, 2, 3, 4. It has a 1, 1, 1, 2, 2, and there's 5 of them, so pentafluoro. One, 1, 1, 2, 2, pentafluorobutane. Now, well, often you can find many halides if we bother putting them on a molecule. Often we use much smaller numbers. And so you might have something like this. Well, in this case, I've got a double bond and I've got a chloro. Chlorines, fluorines, bromines, all the halides act more like subgroups. So your goal in this case is to have your double bond be the lowest number possible. And so the double bond wins. It is 1, 2, 3, 4. Otherwise, we could have gotten chloro at carbon 2 if we'd numbered 1, 2, 3, 4. But like I said, while they are technically functional groups, your halides are about as low importance as possible. So they lose, the double bond trumps them. You want that double bond as low as it can get. And so this is a 4 carbon long. It's going to be a bute 1-ene, and it has a 3 chloro. 3 chloro bute 1-ene. And so halides are just an extra prefix. If you have a mix of subgroups. Let's put 2 methyls, a chloro, and a bromo. Let's do this. Well, 1, 2, 3, 4, 5. This gives us methyls at the 2 position, so that's our lowest first thing we've run into. It's 5 long, so it is a pent. And they are all single bonded carbons, so it is a pentane. I have 2,2-dimethyl. I have a 3-chloro. And I have a 3-bromo. When I put these together, it goes alphabetically. And so bromo beats them all. It is a 3-bromo, 3-chloro, 2,2-dimethyl pentane. And so the halides act just like subgroups we learned for the carbon chains. They just go out in front, and you tell what carbon they are attached to. But halides are rather important. There's definitely a lot of starting materials in organic synthesis that utilize a halide. They tend to be pretty good at leaving the carbon, allowing other things to take their place. Hydrogens don't do that. So an alkane is really hard to swap a hydrogen off and put something on its place. But a haloalkane, a carbon that has a halide attached, that is much easier to replace. And so they're useful synthesis tools.